All right, let me read this, number 5. Consider the set of all fractions x, y, where x and y are relatively prime. There's a footnote there. And it says, in number theory, two integers x and y are said to be relatively prime, or mutually prime, or coprime, also written coprime, is the only positive integer factor that divides both of them as 1. So reduced to lowest terms, let's say. All right, let's write this down and see if I can figure out what they said. So x over y. And again, x and y are integers and are relatively prime, right, to reduce to lowest form. So let's say it says over here, they're positive integers too. I can see that. How many of these fractions have the property that if both the numerator and the denominator were increased by 1? Let me write this over here. So the numerator and the denominator were increased by 1. The value of the fraction, well, the fraction's x over y, would be increased by 10%. Well, to be increased by 10% means 1 plus, that's going to be 10 over 100. All right? Well, I gotta figure this out now. And this is going to be x plus y. I'm going to have to go to the whiteboard to do it, by the way. And let's see what you get there. That's really 1 plus 1/10. Let me make this over here. 1 plus 1/10. And that's going to be a common of 10. That's going to be 11/10. And then you get x times y. All right. I guess what I'm going to do now is probably get rid of the fraction. All right. So I'm going to multiply both sides by 10y and y plus 1. Well, 10y, that disappears. That's pretty good. And what do you get there? Let's see, 11xy plus 11x. This disappears. You get 10xy plus 10y. I want to take a look at that. And I'm looking at that, I wonder what to do about that. Well, maybe solve for like either x or y. Well, let's take a look at this over here. You get minus xy. I subtracted this from both sides. Plus 10y is equal to 11x. I'm going to factor out a y. And you get 10 minus x equals 11x. Now, of course, it's time to think. All right, so and what do I know? Well, these are integers, right? So both sides have to be integers. You can't have fractions, by the way. They're integers. We know that much. So I know y must divide. Let me think about that. Must divide into 11x. But we know y doesn't have any factors in common with x. So that means that the only possibilities for the y could be 11, or the y could be 1. All right, let me just tell you what we know about this over here. That these things are integers. 10 minus x is an integer, y is an integer, 11 is an integer, x is an integer. And I know that y does not go into x, by the way. It's in lowest terms, by the way. So there's no factors common between x and y. So if the y is going to divide both sides, it would have to either be 11 or 1. All right? So let's take a look at it. And I'm going to try y to be 1 first and see what happens over here. See if I can understand what that is. If y is 1, what would you get? You'd get 10 minus x equals 11x. And I'm hoping I can figure this out, by the way. And what happens over here, I get 10 equals 12x. And unfortunately, x is not integer now. So this is not possible because x is not an integer. Well, let's see what happens when it's 11. So 11, and you get 10 minus x, a little more complicated, equals 11x. And what do you get there? Let's see, you get 110 minus 11x equals 11x, 110, that equals 22x. Oh yeah, look at this. X is what number? X is 5, because 5 times 22 is 110. So I think I found it. And what did I find here? I guess we found that y is, what's y? Y is 11, and x is 5. Let's go back and read the question though, and I have to do that, go back, and I know 11 and 5 at this point. What was the question? Consider all fractions. I did that. Consider all fractions x over y, where x and y are relatively prime, positive integers. How many of these fractions have the property that if both the numerator and denominator increase by 1? Well, only one does. And what's that going to be? 5/11ths. Only one. And we're officially done. Thank you. Oops.